So we are starting base theorem, exercise 19A from OPM. Question number 1. Bag A contains 2 white and 3 red balls. White and red 2 and 3. Bag B contains 4 white and 5 red balls. Okay, so they are asking you they are telling you that one ball is drawn at random from one of the bags and it is found to be red. So we are getting a red ball over here. Okay, a red ball. But in which probability they are asking, just read that. The probability that it was drawn from bag B. So they are asking you that a red ball was drawn, but then what is the probability that it came from bag? So Bayes' theorem says that take the specific case, red from bag A, sorry, bag B, because the probability is asked from bag B, upon red from bag A plus upon total number of cases, red from bag B. So this probability is you have to add in the denominator and the specific case will be there in the numerator. Okay, so this is all about Bayes' theorem. Every problem will be simple. So it will be 5 by 9. Probability of getting a red ball from bag B is 5 by 9 upon 3 by 5 red from bag A and 5 by 9. Okay. So to solve this, you'll get the required answer. Okay. So red from bag B upon total number of cases. Second problem, you can take it for self-study. Okay. Let's go to the third problem. Question number 3. Suppose 5 out of 125 5 men out of 125 women out of 1000 are good orators. A orator is selected at random. Okay. Find the probability that the male person is chosen. Assume that there are equal number of men and women. So men and women, 100 and 1000. So out of 100 good orators are 5, and out of 1000 the good orators over here in the female category are 25. Okay. Now we have to assume equal number of men and women. So I'm just making this 1000. So this naturally will become 50. 5 out of 100 means 50 out of 1000. Okay. So we require the probability of a male good orator. So specific case 50 upon 1000 male good orator. You read the problem, see it's pretty clear. Upon all possible cases 25 upon 1000. So if you solve this, you'll get the answer. Okay. Question number 4. Question number 4, I think, yes, we'll discuss that. Suppose that 5% men and 0.25% of women have gray hair. Okay. A gray haired person is selected at random. What is the probability that the person is a male? So let total persons be 100. Okay. Then let men be 50 and women be 50 because equal number of male and female. Okay. Out of men, 5%, 5% of 50 are having gray hair. I'm just writing GH. Okay. And out of women, 0.25% of 50 are having gray hair. Okay. So we require a gray haired person and that person should be a male. So specific case male upon this upon total number of cases. So here down you can take 50 common and then strike it out with the numerator. You can solve this on your own. You can also cancel out the percentages also. Not really a problem while solving this. Question number 5. Okay, a company has two plants to manufacture bicycles. Sorry, a company has two plants to manufacture scooters. Plant one, it has 70% of the production. Plant two has 30% of the total production. Okay, from plant one, standard quality, standard quality scooters are 80%, and from plant two, standard quality scooters are 90%. A scooter is picked up at random and found out to be standard quality. So we have a standard quality scooter, but then they're asking that what is the probability that it came from plant number two, standard quality from plant number two. So specific case, 90% of the total production upon total number of cases, 80% of the total production plus 90% of the total production. So plant two upon plant one plus plant two. Okay, so this is how you calculate. Calculators are there, so you can just plug in the values and get the answers. You can simplify on your own as well. Okay, let's go to question number 7. 6, you can try it at home. A person A has an alarm which will ring at the appointed time with probability 0.9. Okay, so probability of alarm alarm ringing, alarm, 1 second, I'll just write over here, sorry, ringing and not ringing. If ringing is 0.9, not ringing will be 1 minus 0. Which will be 0.1. If the alarm rings and if the person wakes up and goes to the examination hall in time, the probability is 0.8. So this is the probability of person reaching in time is 0.8 if the alarm rings. And if alarm does not ring, the person wakes up on his own and goes to the examination hall on time. So person reaching in time equal to 0.3. This is given. Now they're asking you what is the probability that a person reached examination hall in time given that the alarm was ringing. So this case, alarm was ringing and the person is reaching in time. Okay. So the answer over here will be specific case, that is 0.9 into 0.8 upon 0.9 into 0.8 plus 0.3 into 0.1. This into this. Okay, upon total number of cases. That generally becomes a sample space for the problem. Okay? Yeah. So let's go to question number 8. Okay. By examining chest X-rays, probability that TB is detected when a person is actually suffering is 0.99. The probability that the doctor diagnoses incorrectly that a person has TB on the basis of X-ray is 0.001. 1 in 1,000 persons suffer from TB. A person selected at random is diagnosed to have TB. What is the chance that he is actually suffering from TB? Now, before you, whenever you see this recording, if you are uh, confused uh, looking at the statements, that's fine enough, but then read the problem 2-3 times. Okay. So TB, suffering, actually suffering, and not suffering. 1 out of 1,000 person is suffering. So this is 1 by 1,000. Okay. So this will be 999 by 1,000. 1 minus 1 by 1,000. Okay, which is 999 by 1,000. Now, if you read the First line, the TB is detected when the person is actually suffering. So that means the diagnosis was correct. TB was detected and he actually was suffering from the disease. That is 0.9. Over here, the TB is detected. The second line, the probability that the doctor diagnoses incorrectly that the person has TB. So TB was detected by the doctor, but then actually he was not suffering. If you read the second and third line, okay. So this is 0.001. This is also given, right? So look at the table which I've, the flowchart which I've given you. Read the question once again. You will be able to understand. So we are supposed to find out in this particular problem the probability of a person having TB. That means is suffering from TB, and it was diagnosed also correct. It was detected also. Okay. So P is equal to 1 upon 1000 into 0.99 upon 1 upon 1000 into 0.99 plus 999 upon 1000 into 0.001. Specific case upon total number of cases. Okay. Yeah. So let's go to question number 9. You can solve this on your own. Shoes are produced by two machines A and B. Okay. 50% of the shoes are produced by A with an estimate of 10% being defective. On machine B, 20% of the shoes are defective. Okay, so we just make some note over here. Machine A and machine B. Machine A produces 50%. Machine B produces 50%. So out of this 50% production, machine A produces 10% defect. And out of B producing remaining 50% of the total production, it produces 20% defective pieces. Okay. So we need to find out the probability that we are getting a defective shoe, but then it was produced by machine A, defective from A. So this is equal to 50% into 10% upon 50% into 10% plus 50% into 20%. Okay. Yeah. Question number 10, you can actually do it on your own. I'll take you to question number 11. Okay. So there are three bags, three urns, urn one, urn two, urn three. Red, black, red, black, red, black, 6, 4, 4, 6, 5, 5. One of the urn is selected at random and the ball is drawn from it. Okay. One of the urn is selected at random. If the ball drawn is red, if the ball drawn is red, what is the probability that it came from the first one? So we require red ball from the first one. Now see, any urn is selected at random. So guys, it can be, you know, first urn, second urn, or third urn. So you can multiply this by 1 by 3. That's really fine. Even if you don't, that will be fine because it will get cancelled in any case. Okay. So probability of getting red from urn 1. So 6 upon 10 upon urn 1, that is 6 upon 10 plus 4 upon 10 plus 5 upon 10. Red from urn 2 plus red from urn. See, even if you multiply 1 by 3 for each of the urns, because there is 1 by 3 chance of getting one of the urns. No? So this 1 by 3 down you can take common and cancel. So that's not really a problem even if you don't take 1 by 3. Yeah. If you calculate this, you'll get the answer. Next problem, that is question number 12. So there are three urns, urn 1, urn 2, and urn 3. Red and black, red and black, red and black. 6, 4, 2, 6, 1, 8. Okay. So they're asking you to get a from red ball from either urn 2 or urn 3. Urn 2 or urn 3. So we require a red ball from urn 2. So 2 by 8, or is addition, or from urn 3, 1 by 9. Okay. And then upon total number of cases, 6 by 10 plus 2 by 8 plus 1 by 9. Specific cases, but then here specific cases are two options now, urn 2 and urn 3. Okay, question number 13 and 14, you can do it on your own. 14 has, a bit of confusion towards the last statement. So I don't think so it's really right in the manner in which they are asking. Okay, let's go to question number 15 on 5. Question number 15, urn A, urn B, urn C. White, black and red. White, black and red. White, black and red. 2, 1, 3. This is 3, 2, 4. And the last one is 4, 3, 2. Okay. One urn is selected at random and two balls are drawn. Now see guys, this time not a single but then two objects are drawn at random at once. Okay. And it is supposed to be red and black. Red and black. One red and one black. So what is the probability that it came from urn B? So P. Probability of getting a red ball from first urn is 4C1 into and black ball 2C1 upon 9C2 upon sample space. Okay. So we are trying to calculate specific case. Specific case is from urn B. 4C1 into 2C1 upon 9C. Okay. We are using combination because more than one ball is drawn at a time. So urn A 1C1 into, just a second. Yeah. So urn 1C1 into 3C1 upon 1C1, 3C1, one black, one red, one out of one and one out of three upon total 6C2, two balls from urn A. Then this two we already know, 2C1 into 4C1 upon 9C2, okay, from B, and then 3C1 into 2C1 upon 9C2. And this combination values you can easily calculate with calculator. Yeah. So question number 16, you can do it on your own. Question number 17 also. Uh, I think I'll just discuss this. Question number 17, I'll just rather discuss, not solve. If you read the problem, see, A, B, C are three manufacturers which are producing 25%, 35%, and 40% output. Total output is 5%, 4%, 2%, which is defective, respectively from all the three. What are the probability that it was manufactured by machines A, B, and C? So A individually weighs theorem. So that is 5% into 25% upon total, 5%, 25% plus 4%, 35% plus 2%, 40%. B individually. So B individually individually will be 4% into 35% upon total. C individually 2% into 40% upon total. And second subpart, it was either done by A or C. Okay. So A or C you have to add 5% into 25% plus 2% into 40% upon total. Okay. So this is how you have to solve this particular problem. You can try question number 18 and 19 on your own. Let me know, discuss it. Okay. Let's go to question number 20. Okay. A card from a pack of 52 cards is lost. From the remaining cards of the pack, two cards are drawn and both are found to be diamonds. Find the probability of the lost card being a diamond. So we are supposed to get two diamonds given that earlier whatever card was lost was a diamond. So case one, let lost card be a diamond. Okay. So P1, what is the probability of getting a diamond which is a single diamond? So it is 13C1 upon 52C1, or rather you can just write 13 upon, because we are just taking one card. Okay, into. Okay, now after one card was lost and it was a diamond, now we are left with only 51 cards. Now out of this 51 cards we require two diamonds. If you read the second line, two cards are drawn and both are supposed to be diamonds. So two diamonds. Now there are 12 diamonds left because one card is lost and that is a diamond. So 13 diamonds were there. Now there are 12 diamonds. So out of 12, any two diamonds will be there upon 53C2. Why 53C2? This is the sample space. One card is lost. Okay. And we are drawing out two cards. So this is diamond upon sample space. Okay. Sorry. This is 51C2. I'm really sorry. 52 are the total cards. One card is lost. So it is 51C2. Fine. Case two. Let lost card not be a diamond. So P2. So there are 39 non-diamonds. So what is the probability of the card not being a diamond? That is 39 upon. Okay. Now what is happening is the total number of cards are 51. And out of this, two diamonds are supposed to be drawn. Now there are 13 diamonds only. 13 is not getting reduced to 12 like the previous case. So out of 13, we require any two diamonds upon 51C2. Okay. And now you're supposed to get two diamonds. You're supposed to get two diamonds provided the lost card is a diamond. So the required probability will be P1 upon P1 plus P2. Fine. Okay. Question number 21. Now, before I go to question number 21, I would say that it's a very tricky problem. So you understand the method, and moreover, like still somewhere some concept is unclear. So I would recommend that don't go into the very depth of it. Understand the steps. Maybe I should say memorize the steps and go ahead. Okay, because some students might get confused in this particular problem. So A speaks truth in 2 out of 3 times and B in 4 out of 5 times. They agree in assertion that the bag containing 6 balls of different colors, a black ball has been drawn. Find the probability that the statements are true. That means they are agreeing. Okay. So probability of A speaking the truth is 2/3. Probability of B speaking the truth is 4 by 5. Okay. So let P1 be the probability that they are agreeing that a black ball is drawn, and both the statements are true. Both are agreeing, and in reality, a black ball is drawn. Okay. So 2 by 3 into 4 by 5 into 1 by 6. Now, why 1 by 6? This is of A. B is also agreeing, and probability of one black ball out of six different balls of different colors. So this will be 4 by 45. Okay. So this is P1. Okay. Now, second part. A is not agreeing. Okay. A is not agreeing, so that probability will be 1 by 3. But then he not agrees to what? He not agrees that the ball drawn is black. Okay. So this particular probability 1 by 3 will be multiplied with 1 out of 5. Because now leave apart the black ball over here. See, here the confusion starts. Otherwise, like you can just go through the method and memorize the steps. 1 by 3 is what A is not agreeing, that A is not asserting. Okay. That means he's not speaking the truth. Okay. And at the same time, a black ball is not drawn. So now there are 5 balls left. Out of 5 balls, there is only one ball which is to be drawn. Okay. So forget about the black ball now. So it has to be multiplied with 1 by 5. So this is 1 by 15. P2, sorry, P of B dash. B speaks truth. Now this time B is not speaking the truth. So it is 1 by 5. Okay. So this 1 by 5 will be multiplied with. Now there are 6 balls. One of the ball is black. So he's not speaking the truth. That means there will be one ball out of any of this 5 remaining balls. So this will be 1 by 25. Okay. And P2. P2 is equal to, they are not asserting. That means they are not true. So that will be 1 by 15 for A, 1 by 25 for B. And what is the probability of getting a non-black ball? Is 5 by 6, because there are 6 balls. So probability of getting a non-black ball is 5 by 6. So this is equal to 1 by 450. Okay. Again and again, just watch this recording so that you know this problem is clear. Now final answer, I'll just write it in green over here. If you read the last statement, they are agreeing, or rather see, the statements are true and a black ball is drawn. So P1 upon P1 plus P2. This is how we'll get the answer. If you have understood this problem, well and good. Otherwise, just memorize these steps and go. Yeah. Question number 22. So this time there are 3 candidates for the position of principal C1, C2, and C3. Okay. The chances, 3 candidates are C1, C2, and C3. The framing is not really good over here. Their chances of selection are in proportion 4 is to 2 is to 3. So this time proportion is given. The probability that if C1 is selected, will introduce co-education in colleges 0.3, C2 is given, and C3 is also given. They will introduce that particular thing. What is the probability that there will be co-education in the college? Okay. So C1, C2. Now C1 being the principal, the chance will be 4 upon 4 plus 2 plus 3. That is 9. This will be 2 by 9 and this will be 3 by 9. The proportion is given. Okay. So the ratio is given, I should say. The ratio is given, and the chance of C1 being the principal is 4 by 9, C2 is 2 by 9, and C3 is 3 by 9. C1 introducing C1 introducing co-education probability is 0.3, that is 30% chance. This is 0.5 and this is 0.8. So this particular part is they will respectively encourage co-education. Now first part is not really Bayes theorem. They're asking that there will be co-education. So co-education will be there irrespective of the person comes into power. Okay, so C1 का power में आने का chance है 4/9 and then into 0.3 plus. Plus means or. C2 comes in power and he will introduce co-education, or means plus. C3 will come into power and he will introduce co-education. So this is P. Fine. So this is the first part of the problem. Second point, co-education is introduced in the college, but then C2 is introducing it. So specific case. This problem is very good actually because it will cover all your concepts. 0.5 into 2.9, 0.3 into 4/9, 0.5 into 2/9, 0.8 into 3/9. So C2 upon C1 plus C2 plus C. Okay. So you can further practice 23, 24, 25, and 27 on your own. I'll take you to question number 26. Okay. There are three coins. One is a one-headed coin having head on. One is a two-headed coin, sorry, having a head on both the faces. So coin one, probability of getting a head will be 100% because both the faces are having head only. Coin two, okay, it's a biased coin. In unbiased coin, the chance is 50-50%. So then it's a biased coin. Probability of getting head is 75%. And coin three, probability of getting head is tails का probability दिया है. So heads का probability will be 60. Tails is 40, so heads is 60. One of the three coins is selected at random and tossed, and it shows head. What is the probability that it was a two-headed coin? This one, the coin one, is a two-headed coin. So this is P1, P2, and let this be P3. So two-headed coin upon all the cases, P1, P2, and P3. Now what next you can do about this particular thing is ISC questions. Okay. And one solved example I'll be solving right now. So that is example number 16. So this is solved example 16 from page number chapter 19, page number 15 of Bayes theorem. It's a solved example. So do this problem. It's very important, I should say. In a test, examinee either guesses. Okay, so the person who is attempting either guesses or copies or knows the answer to MCQ with four choices. Okay, so guys, in this problem, see, look at the first statement over here. A person can either guess or he can copy or he knows the answer. Okay, so he's going to make a choice. He's going to either guess or copy or he knows the answer. As per that, he will attempt that question. The MCQ has four choices. The probability that he makes a guess is 1/3, and the probability that he copies the answer is 1/6. The probability that his answer is correct, given that he copied, is 1/8. Find the probability that he knew the answer to the questions, given that he correctly answered it. Once again, a very tricky uh, thing to understand everything. Okay. So left hand side, I'll just write the conscious choices, or rather, I just write it horizontally. So probability of guessing, he's making a conscious choice of guessing, is 1/3. Probability of making a conscious choice of copying is 1 by 6. And probability of making a conscious choice of knowing that he knows is equal to 1 minus 1 by 3 plus 1 by 6. 1 minus the rest of the. So this is equal to half. Now, by guessing, getting the right answer, getting the correct answer is, so see, it's an MCQ. There are four options are there. So one of them has to be correct. So probability of getting the correct answer is 1 by 4. Correct answer by copying. Now this is given in the problem. See, the probability that his answer is correct, provided that he copied, is 1 by 8. In the last case, correct answer. Correct answer by knowing. So if he knows the answer has to be correct, so it has to be 100%, which is 1. Okay. So P1 is equal to 1 by 3 into 1 by 4. Correct answer by guessing. P2 is equal to 1 by 6 into 1 by correct answer by copying. P3 is equal to correct answer by knowing, 1 by 2 into 1. So now let us understand the main question over here. Find the probability that he knew the answers to the question given that he correctly answered. So he got a correct answer from knowing. So the final answer over here will be, as per the base theorem, it will be P3 upon P1 plus P2 plus P3. Okay. Now you can also solve ISC questions in this particular chapter. This problem is over, but then ISC questions also you can solve, which is there in OPM. That will be a good thing to go ahead. Base topic is over.